This is a problem which you're gonna apply the Bernoulli equation to solve the pressure in that side. Here they give you the diameter here, and the diameter here, and then they give you the fluid. The fluid in that hand. You're dealing with a hose. Basic water came in here and can get out here. So what we can do, we can apply the Bernoulli equation. So we know Bernoulli equation is P1 plus V1 square plus Z1 elevation should be equal to P2 plus V2 square plus Z2. Here we can state Z1 equal to Z2. So because they're equal, we can cancel. Also because this pressure in that hand, the pressure gonna expose, like this side is exposed to the air, so we can see that if we're using gauge pressure, this one should be 0. So now what we have, the pressure will be 2G V2 square minus V1 square. So this one is basically 1/2 of the density of water. Like I put 1/2 the density of water because this one, the specific weight is times G, right? If we divide both sides by G here, so we have the density. So that's why I put the density in place of this one. So now, this is the formula to calculate the pressure. But as you can see, we have the density. We know the density of water. Basically, what we need here, we need those two velocities, the velocity 1 and the velocity 2. We can calculate velocity 2. Velocity 2 will be Q over area 2. So what is Q? Q, we know what it is, 250 gallon per minute. So we're gonna convert it into cubic feet per second. So basically 1 minute equals 60 seconds time, we know 1 cubic feet equals 7.48 gallon. So everything over this one. So we know this, it's 1.25 inches square. So it turned out to be the velocity 80.7 feet per second. So let's do the same thing for V1. V1 will be Q over A1. Same thing here. Same thing here, the only difference here is the area. We use this. So velocity, as you can see, the velocity in here, because the area is bigger, the velocity should be smaller here. Like we turn out to be 11.34 feet per second. So now you have velocity 1 and velocity 2. You can't just plug it in here. You can't plug them in here to calculate the pressure in here. So pressure here will be 1/2 times 194 feet slug slug per feet cube time what we have here was velocity 2. So velocity 2, remember, was 8.7 square minus 1134 square equals. So what is P1? I'm gonna plug it in the calculator quickly. P1 turned out to be 6,082 pound per feet square. 6,192 pound per feet square. Or you can convert it in PCI if you want it, and so it will be 43 PCI. That's how you actually calculate those kind of problems using, like, when you have pressure, like when you have to calculate pressure, you use the Bernoulli equation to do it. I hope I didn't do any major mistake. I hope you could follow it pretty clearly, and have a good understanding of the Bernoulli equation.